Hi! This is the final step in creating the runner game. First, let's review the animations we created in the previous tutorial. In addition to the idle, run, jump, and air motions described in the production process, there are additional double jump, land, and die motions. This tutorial uses idle, run, jump, air, and double jump motions. Now run bake and send the character to the Unity scene. You can see the character that appear in the Unity scene. The character is rendered too bright. Because the character made with any portrait are affected by light, they appear brighter than the original image in Unity, which is basically set to slightly brighter. Delete the directional light. You need to initialize the ambient light, and you can do it right in the Any Portrait editor. Open the Any Portrait editor again, and change the color of the ambient light to black in the Setting tab of the Bake dialog box. Now, in Unity scene, the character is rendered in its original color. We do not need skybox of the background. Now change the camera settings. Change the camera's clear flags to solid color and specify the color. Change projection from perspective to orthographic. Changing to orthographic resolves the rendering weirdness. Next, change the size and clipping plane settings. If the far value of clipping planes is too large, an error may occur when calculating depth. If not necessary, reduce the value of far moderately. These are the player character and a tile as the background. The player character runs or jumps, judging whether or not it is in conflict with the tiles. When you add colliders to the player and tiles, Unity will automatically perform the physical calculations. Create a new game object and name it Player. Change the location and change runner created by any portrait to be a child of player. Now, you can manipulate player instead of runner character. Adds components for physics to player. Create a collision area by adding Capsule Collider 2D. Sets the size and position of the collision area to match the character's image. And add Rigid Body 2D. When you play the game, Rigid Body 2D works and the character falls down due to gravity. Next, create a quad instead of a tile for testing. Add Box Collider 2D. Modify the size and position of the quad. When you run the game you will see the falling character landing on the quad. Let's change the properties of Rigid Body 2D. For improved physical processing, change collision detection to continuous and change the interpolate property from none to interpolate. If you run the game again, it's hard to see a big difference yet. Increase the gravity scale to increase the speed at which the character falls. Now the character is falling a little faster. And one more important property. In 2D games, it is essential to constrain the z-axis rotation. Currently, it is difficult to know why the freeze rotation property should be constrained because the terrain is flat. Let's see what happens when freeze rotation is off for a tilted terrain. Since the player is not rolling, freeze rotation must be turned on. The next step is to create a script to move the player character. If you have a basic knowledge of finite state machine, this script will not be much difficult. To use the functions of any portrait, specify that you will use the AnyPortrait package. To control the runner character of the AppPortrait class, declare a variable of type AppPortrait as public. To create a state machine, create an enum variable named state. This enum variable has two states, idle and run. Create the isFirstFrame variable of type bool. This variable has the value true, when it is the first frame updated after changing to the current state, otherwise it has a value of false. This variable is useful when you want to write initialization code within a state. Initialize the values of the variables in the start function. In the update function, it is recommended that the core code of the finite state machine be created using switch. The update idle function or the update run function is executed according to the idle or run state respectively. Write the update idle function. Checks the isFirstFrame variable to play idle motion in the first frame of the idle state, and switches the isFirstFrame variable to false. This code is often used. In this state, the code is written, so that the character runs by pressing the left and right keys of the keyboard. Use the changeState function, which will be created later, to change the state from idle to run. This is the update run function that is executed when it is in the run state. Write code that moves the character to the direction in which the key is entered. First, run motion is played in the first frame in the run state. For smooth playback, use the crossfade function instead of the play function. Holding down the left arrow key on the keyboard will cause the character to move to the left by 10 per second. By default, the character is looking to the right, so when moving to the left, you need to invert the X value of the scale. Conversely, pressing the right arrow key on the keyboard will cause the character to move to the right by 10 per second. You can make the direction of movement and the X value of scale to be plus. If none of the directional keys on the keyboard is pressed, the character will return to the idle state. Let's write the most important state conversion function in finite state machine. If the argument next state is different from the current state, change state and change isFirstFrame to true. As soon as the state changes through this code, the initialization code inside the state will work. Now let's apply this script to the Unity scene. Add the created script to player and assign runner to the portrait variable. Make the terrain a bit bigger for testing. You can run the game, and move the character left or right, by pressing the left or right arrow key. However, if the background overlaps with the character, you can see that it is rendering somewhat strange. Moves background objects backward. This method is quite useful, because the 2D physics engine works well, even with different Z values. Now, even if the background and character overlap, they will be displayed normally. The next step is to create a tile map. Before writing a script, I'll explain how to implement it. In this example, one tile image is copied and a tile map is placed in a grid. Create multiple copies of the tile using the instantiate function. Then use the locate tile function to create each tile at the appropriate position. I'll explain the rules for placing tiles. There is a base position, named map left position. Based on this location, it is determined how many tiles can be placed up and down. It also determines how many tiles are placed on the x-axis. These values are defined as variables named tile count. Let's see how the tile map is updated as the character runs to the right. Each time the character moves, a variable called player pose x is incremented. But actually, the character is in the middle of the screen, and the tile map is moving in the opposite direction. If the value of player pose x is greater than tile size, then the character has moved by the size of one tile. Then the makeMap function is executed and new tiles are placed. Let's remember this process and write a script. Create a new C# script named Manager. A transform object called SourceTile is the tile object we will prepare. We will copy several source tile and place the copied tiles into a tile map. The copied tiles will move to the location, loaded tile group and wait. Since the copied tiles should not be visible on the camera, you should decide where to hide them in this way. Let's create variables for tile placement. Map left position is a transform object on the left of the screen that is the base for the tile map. Tile count x indicates how many tiles should be placed along the horizontal axis. Tile count upper y and tile count lower y indicate how many tiles can be placed up and down on the y-axis. Tile size means the size of the tile. The following are list variables. Tile list all is a list containing all copied tiles. Tile list live is a list of copied tiles that contains only those placed in the tile map. The remaining variables are the variables used to create the tile map. Tile count y, like tile count x, determines how many tiles are created on the y-axis. Tile list size means how many tiles will be copied and is also the size of the list variable tile list all. Tile index is an index variable that determines which tile to select from among the pending tiles and places it as a tile map. Created tile pose x is an index variable on the x-axis that indicates how far away the last tile currently placed is from the reference point. Prev ground height is the variable used to determine the height of the terrain. This variable has the height value of the previously created terrain. Write the start function. You need to write code to initialize the variables and copy the tiles. Move source tile to the coordinates of loaded tile group. Initializes the variables related to the number of tiles. Tile count y is the sum of the values of tile count upper y and tile count lower y. Tile list size is the total number of tiles copied. Basically you can copy as much as the size of the tile map, but you may actually need a little more tile. So I multiply the size of the tile map multiplied by tile count x multiplied by tile count y by 2. Now copy the tile by tile list size. Use the instantiate function to copy the game object of source tile, move it to the location of loaded tile group and add it to tile list all. If you are finished copying the tiles, call the initMap function to initialize and create the tile map. Write the initMap function. This function is called at the beginning of the game, either at the start function or at the point of restart after the game is over. Call the hide all tiles function to hide all generated tiles out of the screen. Initialize the tile index, created tile pose x, and previous ground height variables. Clear the tile list live variable to initialize the tile map. Finally, we call the makeMap function. Entering true here, as an argument, means that the makeMap function was called when the game was initialized. On the other hand, enter false for the argument if it is executed during the game. Let's write the makeMap function, which is the most important in this game. Before writing the function, let's see how the function's code works. It is the first loop. Created tile pose x refers to the x-axis index on which the tile map is created. Currently, the tile map is not generated, so it has a value of 0 and it points to the left. Calculates the height and length of the terrain to be created. The length of the terrain is 3 or 4 random values. The height of the terrain is specified by a random value from -2 to 2, based on the height of the previous terrain. The shape of terrain are stored in local variables tile ground length and tile ground height respectively. Once the size of the terrain has been determined, the tiles are placed. If all tiles are placed, created tile pose x is incremented, and the first loop is ended. The second loop is started. Unlike the first loop, one more fun feature is added. An empty space can be set between terrains. If you make an empty space with a value between 0 and 2, created tile pose x jumps by that value. Now, the shape of the terrain is determined as before. Tiles are placed by the shape of the determined terrain. The last loop. The shape of the terrain is calculated as before. When tile map is generated and the loop is ended, created tile pose x is larger than tile count x at this time. This means that the placement of the tiles within the screen is complete. When this condition is true, the loop is terminated. Now let's write a script. In the beginning of a function, if the function does not need to be processed by an if statement, use the return statement to terminate immediately. Write the while statement. Initially create a tile ground length variable and set the length of the terrain the tile will be placed on. If this function was called when initializing the game, the first load argument would be true. At that time, the length of the terrain will be as long as tile count x, so that the flat terrain will appear longer in the beginning of the game. Conversely, during a game, you have a random value of 3 or 4, as described earlier. This time we will calculate the height of the terrain. Create a tile ground height variable and set it as high as the map left position is located when initializing the game. In this case, use tile count lower y value. Conversely, when updating a tile map during a game, the height of the terrain is determined by adding a value between -2 and +2 from the previous terrain height. And use the clamp function to prevent it from being too high or too low. The following sets the spacing between terrain. Only works when first load is false, and has a value between 0 and less than 3. Increases create tile pose x by the calculated distance. We have decided the height and the length of the terrain, so it is time to place the tiles one by one. Place the tiles using 2 for statements and the created tile pose x variable. Let's use the locate tile function, which I will explain later. After placing all the tiles, increase created tile pose x by the length of the created terrain. Update the prev ground height variable. If created tile pose x is bigger than tile count x, it means that the generated tiles are placed on the x-axis as much as the screen length. Therefore, in this case, use break to end the while statement. Let's write a function called locate tile that will place the tiles into the terrain information. There are 2 int type arguments, tile pose x and tile pose y. This value indicates the location of the tile to be placed. The important thing is, which tile should be selected from among the copied tiles. In this example, let's implement this simply by using the tile index variable. Select a tile with the same index as tile index in tile list all, and add this tile to tile list live. Increase tile index by 1, and set it to 0 if it reaches the end of the list. The position of the referenced tile is the same as the screen. Since tile pose x and tile pose y index, their position is calculated by multiplying by tile size. The position of tiles is calculated based on map left position and tile count lower y. Finally, let's write a function called hide all tiles that is used in the initMap function to initialize the tile map. This is a simple code that moves all tiles to the location of loaded tile group. Once the script has been written, let's apply it to the scene. Create a game object named Game Manager and add the created manager script. Let's make a tile. Create a new quad. Delete a mesh collider. Apply the material that contains the pre-created tile image. We changed the properties of the mesh renderer to prevent shadows or other lighting effects from being applied. Add a box collider 2D. Change the size of the tiles. Makes it the right size compared to the character. I set scale to 5. Let's make this tile copied into several pieces and applied to the game. Create a new game object corresponding to the map left position variable. Then move it to the left of the screen. Create a game object corresponding to a loaded tile group and move it away from the camera. Select Game Manager, then connect the tiles or transform objects in the inspector. Now let's play the game. You can see that a tile map is being created. Press the left and right arrow keys to move the character on the tile map. What happens if the settings of Game Manager change? I tried changing tile size. You can see that the tiles are not positioned correctly. You can see that tiles that were copied but not yet placed are created in the same location and then waiting. The next step is to create a one-button running game in earnest. Please note that we will modify both the player and manager scripts. First, let's modify the script for player. Add the variables. To write the code related to the jump, declare a variable that directly references rigid body 2D, add a variable that refers to the manager that generated the tile map, add speed and hit test point variables to check character movement and collision. Add toState to a finite state machine. Jump state by the user's input and fall state where the character falls are added. Declare more private variables. Jump count is a variable used to determine whether a double jump can be performed in the air. The variables is hit x by point and is hit y by point mean whether the character has collided with the tile at the front and at the bottom respectively. Default pose is the starting position of the player character at the start of the game. Delta move x means how far the character has moved along the x-axis for one frame. Initialize some variables in the start function. Modify the update function. First, initialize the newly added delta move x variable to 0. We will create a function called hitTest to check for conflicts precisely. Call this function. Add two update functions for the added jump and fall states. Let's write the hitTest function. If you only use physical calculations with rigid body 2D, it is difficult to know exactly which motion of the character should be played and what state it should be switched to. You can use the overlap point function in Physics 2D to determine if collider has collided at a specific location. This function is called for the x and y axes. Since hitTest x point is located in front of the character, you can check if the character has hit the wall as it ran. HitTest y point is located slightly below the character's foot, so you can check whether the character is currently standing on the ground. You can limit unnecessary collision checks by limiting to a layer named map. We now store conflicts for the x and y axes in the isHitX by point and isHitY by point variables. Checking these variables will tell you if the character can run forward or if the character should drop. Modify the update idle function for the idle state. Delete the existing code that processed the left and right arrow key input. Instead, use any key down to change the character to run by pressing any key. Also modify the update run function. Deletes the code that moves according to the direction key or returns to idle. Instead, let's use the variables isHitX by point and isHitY by point. If isHitX by point is false, it causes the character to move to the right, by speed per second. Be sure to check the difference between true and false. The state may change depending on the collision on the y-axis. If isHitY by point is false, the character is not currently on the ground. If so, the character will be forced to the fall state. Conversely, when the character is on the ground, the character can jump if you press any key. At this time, switch to the jump state. Let's write the update jump function. The jump state includes code that is processed while the character is jumping and is in the air. The first frame in the jump state will play jump motion. Use the crossfade function to continue playback from the previous motion. Then call the crossfade queued function directly to make air motion play when jump motion finishes. We know that jump motion is not a loop animation. And initialize jump count to 1. There are many ways to move the character up, but I used the add force function of rigid body. Use the add force function to apply a momentary force to the character in the upward direction. When jump count is 1, pressing any key can cause the character to jump once more in the air. At this time, double jump motion is played, and then air motion is played. We used the play function instead of crossfade to show that the motion is switched quickly in the air. To jump once more in the air, you need to set the current speed of rigid body 2D to 0 before using the add force function. Otherwise, the force applied by the double jump may not be applied as intended. Set the value of the velocity property to 0, and use the add force function to make it jump once more in the air. Since the character jumps for the second time, change jump count to 2. If it does not collide with the x-axis, move it to the right by speed as in the run state. Check the collision on the y-axis to see if the character has landed. Note that the character may have collided with the tile at the start of the jump. At this time, however, the character should not be in the run state. Therefore, we use the direction of the y-axis speed of rigid body 2D to distinguish it. If the direction of the speed collides with the tile facing downwards, this means that the character has landed while falling. In this case, switch to the run state. We then create an update fall function. This function is executed with the character falling off the tile map without jumping. Most of the code is the same as update jump because it is very similar to jump. In the first frame of the fall state, air motion is played immediately. Although the character has never jumped, set jump count to 1 to limit the number of double jumps. The other code is the same as update jump. Finally, write the function late update. Late update is a function called by monobehavior and will be executed after all update functions are executed. In the runner game, the player character only moves in the y-axis on the screen, while it is fixed in the x-axis. But obviously, we made the character move on the x-axis, using the translate function and rigid body 2D. We use that point in reverse, to move the tile map backward, in the late update by the distance that the character has moved for one frame. There is a default pose variable that stores the position of the character in the start function, and current pose is the position of the current character since the update function was executed. Delta move x stores how much the x-axis has moved in one frame from the starting position. Y and Z positions maintain the value of current pose, and only the x position moves to the initial position by using the value of default pose. Then pass the value of delta move x to the manager script. The onRunner player moved function is a new function that will be created in the next step. Open the manager script and modify it. We want to add logic about the tiles map is updated as the character moves and the camera is following the movement of the character. Declare the variables. Add a variable to associate with the player script. To make the camera follow the player character, set the camera as a variable, and set the maximum and minimum positions of the camera as public variables. Create a player pose x variable where the player's position changes are accumulated and stored. This variable plays the most important role in updating the tile map. Fill in the empty update function. Let's write code that moves the camera to prevent characters from fading off the screen. Create a code that moves only 10% to the player's y-axis position. Because this code works every frame, the camera moves pretty smoothly. Modify the locate tile function. You must compensate for the position of the tile as the character moves forward. Decrease from the x-axis position by player pose x, which is the distance the character has moved. Let's create logic that updates the tile map as the character moves. Create an onRunner player moved function that appeared earlier in the player script. The argument to this function, delta pose x, is the distance the character described above has moved during one frame. Moves the tiles placed by tile map backward by delta pose x. Let's move the tiles back and place the tiles further. Let's look at the process with the code below. First, add delta pose x to the player pose x variable. Player pose X is stored with accumulated delta pose X. And now, the x-axis index of the tile map, created tile pose X, is pointing to the end of the tile map. Player pose X is 0 when the character is not moving. Player pose X increases by delta pose X. Because the tile map moves backward, player pose X is equivalent to moving forward relatively. If the character has moved more than the size of the tile, you must create a new terrain. This is the case if player pose X is larger than tile size in the if statement. First, subtract tile size from player pose X. And since the index of the tile map is changed, created tile pose X is reduced by 1. Move to the left to exclude tiles that leave the screen from the tile map. I removed the tiles that were moved to the left, a lot more than map left position, from the list, using a function in the list remove all. Finally, we call make map to create a new terrain. Let's apply these scripts to the Unity scene. Create a game object for the character's collision check in the front and bottom, respectively. And connect to variables in the script. Select the game object that contains the manager script and connect the appropriate targets to the newly added player and the game camera respectively. Then check the moving range of the camera and input it. After confirming the settings of the tile map again, open Project Settings. Select Tags and Layers and add a layer named Map. Then select the tile and change the layer to Map. Now run the game. The character jumps forward while jumping. Terrain of various heights continues to appear. The camera's field of view seems to be somewhat narrow. I adjusted the size property of the camera and tested it again. This time, the moving range of the camera seems to be a little narrow. Check the moving range of the camera and reflect it in the property of Manager. Now the camera is chasing the player pretty well. The collision check works normally, so that the player does not move forward, in front of the wall. It's okay for a character to jump or fall. But this game does not yet have a game over. In this example, we will make the game end and restart, when falling into the space between terrains. Open the script for player and add a function named onPlayerDied. When this function is called, the velocity of rigid body 2D is initialized and the character is returned to its original position. The finite state machine returns to the idle state. Open the manager script. Add a variable called death zone. When the player character is below death zone, the game ends. In the update function, the player's position is compared to death zone to determine whether to end the game. If the character is below death zone, the onPlayerDied function just created is called. It then calls the initMap function, which returns the tile map to its initial state. Let's create and apply death zone in Unity scene. Create a new game object and link it to the manager variable. If the player character falls below death zone, you will see the game restart. The position of death zone is too high, so move it down. The logic of the game is now complete. Finally, let's conclude by adding the background of the game briefly. Use a sprite or quad to add a gradient background. Check the moving range of the camera to make it big enough. When you run the game, you can see that the runner game has been completed. The animation was played according to the character's condition, and it became a fairly good game. Now you can upgrade this to create a fun game like demo. I hope you will make interesting games using any portrait. Thank you.